Dear students, welcome to the second semester video classes. Hope that you have written the exams well. Keep on preparing as the board exams are not far away. In this semester, we are going to start with the chapter 9. This chapter deals with progressions, that is, the two types of progressions, arithmetic and geometric progressions. But geometric progressions is not a part of reduced syllabus. Therefore, we shall study only about arithmetic progressions. Before learning about arithmetic progression, we should know what is a progression. So let us see what is a progression. A progression is a sequence of numbers that advances in a logical and predictable pattern. Here we have some examples. The first example, 1, 4, 7, 10, etc. Then we have 3, 6, 12, 24, etc. In these patterns, if a few terms are given, we are able to find out the succeeding terms. These kind of patterns are known as progressions. So in the first example, it is clear that the difference between the first term and the second term is 3. Similarly, the difference between the second term and the third term is also 3, and it continues so. That means the difference between any two consecutive terms is 3, or it is a common number. Now in the second example, the quotient between any two consecutive numbers will be same. That means 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2, etc. So we can say that these numbers have a common factor. So with the help of that common factor, we are able to predict the next term. In the first example, we have a common difference between the consecutive numbers. This progression is said to be an arithmetic progression. In the second example, we have a common factor between the consecutive numbers. This progression is said to be a geometric progression. Hence, we can define the arithmetic progression as follows. A list of numbers in which each term is obtained by adding a fixed number to its preceding term, except the first term, is called an arithmetic progression. In other words, a list of numbers is called an arithmetic progression if and only if the difference of any term from its preceding term is a constant. Now, some important points about arithmetic progression. The constant which is added to any term to get the next term in an AP is called common difference and is usually denoted by D. Common difference may be positive, negative, or 0. Here we have to note down one thing. If the common difference is positive, the pattern will be increasing. If the common difference is negative, the progression will be decreasing. And if it is 0, then terms of the progression will be same. The first term of an AP is usually denoted by A. The first, second, third terms are denoted by A1, A2, A3 or T1, T2, T3, etc. Obviously, the nth term is denoted by AN, or the 50th term is denoted by A50, the 100th term is denoted by A100, and so on. We can get the value of D by subtracting AN from AN plus 1. Here we have some examples of arithmetic progression. 1, 4, 7, 10, etc. Minus 5, 0, 5, 10, 15, etc. 4, 1, minus 2, minus 5, minus 8, etc. Minus 3, minus 3, minus 3, etc. In the first one, we have common difference of 3. And in the second one, we have a common difference 5. In the third one, we have a negative common difference, that is minus 3. And in the fourth one, the common difference is 0. That means the terms of the progressions remain same. An arithmetic progression which contains finite number of terms is called a finite arithmetic progression. In the given example, it is clear that this progression ends at 40. That means this progression has only a limited number of terms. So it is a finite AP. Now, an arithmetic progression which contains infinite number of terms is called an infinite AP. It is very clear that the given progression does not end. That means the terms continue as 15, 20, 25, etc. That means it is an infinite AP. The general term of an arithmetic progression can be obtained by the formula an is equal to a plus n minus 1d, where n is a natural number, a is the first term and d is the common difference. Suppose we have to find out a5 or the fifth term. So we have to apply the formula as a5 is equal to a plus 5 minus 1 into d, that is a plus 4d. If we have to find out the 10th term, we have to apply as a10 is equal to a plus 9d and so on. The difference of any two terms of an AP can be obtained as an minus am is equal to n minus m multiplied by common difference d, where m and n are natural numbers and d is the common difference. The nth term from the end of a finite AP consisting of m terms can be obtained by the formula a plus m minus n into d, where a is the first term and d is the common difference. M is the number of terms in the progression and n is the position of the required term from the last position. Suppose we had to find out the third term from the last from a progression consisting of 20 terms. So here in that case m is equal to 20 and n is equal to 3, because we have to find out the third term from the last, and hence we have to apply the formula like this, provided the first term and the common difference, first term plus 20 minus 3 into common difference. We can also obtain the middle term of a finite AP with n terms. If n is odd, then the AP has only one middle term, and that term is n plus 1 by 2th term, or the term at the position n plus 1 by 2. If n is even, then the AP has two middle terms, and they are the terms at the positions n by 2 and n by 2 plus 1. Now let us apply this formula in some of the problems. Here we are solving exercise 9.2. The first question. Find AP whose nth term is 7 minus 3n. Also find the 20th term. Here the general term of the AP is given, that is 7 minus 3n. Nth term is 7 minus 3n. Hence we can find out the first term by substituting the value of n as 1. Hence a1 is equal to 7 minus 3 into 1, that is equal to 4. Similarly we have a2 is equal to 1, a3 is equal to minus 2 and a4 is equal to minus 5. Hence the required AP is 4, 1, minus 2, minus 5, etc. Now following the same format, we can find out the term a20, that is 7 minus 3 into 20, that is equal to minus 53. Now question number 6, first one. Which term of the AP 3, 8, 13, 18, etc. is 78? Here the AP is given, that is 3, 8, 13, 18, etc. And a term is given, we have to find out the position of the term. That means the value of n we have to find out. Given that the first term is 3, and we can also find out the common difference by subtracting the first term from the second term or by subtracting any two consecutive terms. Hence we have a is equal to 3 and d is equal to 5, and we have to find out the value of n by applying the given values in the formula a plus n minus 1 into d is equal to the nth term. We can find out the value of n. Hence we have 3 plus n minus 1 into 5, because the first term is 3 and the common difference is 5. After substituting the values of a and d, we get a linear equation in n By solving it, we can easily find out the value of n. Hence, we get n is equal to 16. That means 78 is the 16th term of the given progression. Next question. Question number 11. Determine AP whose 5th term is 19 and the difference of the 8th term from the 13th term is 20. Here we have A5 is equal to 19, or we can form an equation here, that is A plus 4D is equal to 19, because we know that the nth term is equal to A plus n minus 1 into D. That means the 5th term is equal to A plus 5 minus 1 into D, or A plus 4D. And so A plus 4D is equal to 19. We also have the difference between the 8th term and the 13th term is 20. That means A13 minus A8 is 20, or by formula it is 13 minus 8 into D is equal to 20. By applying this formula, we can find out the value of D, that is D is equal to 4, and hence A is equal to 3 by substituting the value of D in equation number 1. Hence, we can form the progression as 3, 7, 11, 15, etc. Now, question number 14. Find the 31st term of an AP whose 11th term is 38 and 6th term is 73. Here we have 11th term is 38 and 6th term is 73. That means we can form two equations. A plus 10D is equal to 38 and A plus 5D is equal to 73. These two form simultaneous linear equations in the variables A and D. By solving them, we get the value of A as 108 and the value of D as minus 7. Now, by applying the formula An is equal to A plus n minus 1 into D, we get A31 is equal to A plus 30D, and that is equal to minus 102.